All right, so you've got this graph, right, and it says here's the function f, and it says here's this area function g of x, okay, and that's going to be defined as the integral from 1 to x of f of t dt, and so this f here is referring to the blue graph here, all right. So then it says compute g of 4 and g of negative 2, all right. So in an ideal world, I would just have this copied. Actually, all right, I'm going to try to really go nuts here. Let's see here. Oh, this might work. Okay, so if I want to compute g of 4, what I'm doing is computing the integral from 1 to 4. Okay, so from 1 here to 4 here. Okay, and so you can see that that's going to be broken up into, well, you have to be sort of careful here. Like, it looks like a triangle there, a trapezoid here. So trapezoid, triangle, and triangle there. All right, and then this right here will have to be negative, right? Because it's below the x-axis. So that's how we're going to compute g of 4. G of negative 2 is going to be the integral from 1 to negative 2, and you're going to have to change that around. You're going to have to switch it so that it's the negative of negative 2 to 1. All right, because you want the lower bound to be less than the upper bound. So you're going to go from negative 2 to 1, and so that is going to be computing this area here, all right, to compute that. So let me show you the work for that. Get rid of this stuff. Yeah. Okay, so first of all, g of 4. So this is the integral from 1 to x. Sorry, not x, 1 to 4 of f of t dt. And sometimes there's some confusion about, like, you know, this is f of t, but the function is in terms of like x's and y's. You don't have to worry about that. This is just referencing the function f. Okay, so to find that, like I said, we've got three things. Excuse me. We have a trapezoid, a triangle, and a triangle. Okay, so let's just find the area of the trapezoid first. Okay, that's going to be 1/2 times the height times the bases added together. And so this trapezoid is sort of like on its end. So the height of the trapezoid is going to be 1. The first base there looks like it has a height of 3, or length of 3. And then the next base there has a length of 1. And so we end up with 1/2 of 4, which is 2. Okay, so there's part of it. And then we'll go get the area of that triangle. The first one there, triangle 1, I guess we'll call it. Triangle 1, that's a bad way to write that. But anyway, it's 1/2 base times the height. The base there is just 1 unit, and then the height is 1 as well. So we get that is 1/2. Sorry. So we get 1/2. And then area of triangle number 2 is going to be 1/2 the base times the height, which I think is the same triangle. So 1 times 1, that equals 1/2. But remember that it's negative because it's below the x-axis. So when you sum these areas, you should get that g of 4 is equal to 2. Questions there?
No.
Okay. All right, and then when we go find g of negative 2, remember we said we're going to have to write that one as the integral from negative 2 to 1 of f of t dt. Okay, and that will be, that's that triangle that has a base of 3, and it looks like a height of 3 as well. So that's going to be 1/2 times the base, which is 3. No, wait, 1, 2, 3. Yeah, 3 times 3. So that's going to be 9/2 for g of negative 2. Questions there?
No.
Okay, so usually those two are not too bad because you can really just take the notation and follow it through and get to the result. The next one is where things start to get a little sticky. So find the instantaneous rate of change of g with respect to x at x equals 2. So that's the derivative of g, at x equals 2. Well, if we take a look at this function g of x, it's this. If I take the derivative of that, in other words, if I find g prime of x by the fundamental theorem of calculus, the derivative of the integral, those are inverses of each other, what we end up with here is f of x. And this right here is probably the most important takeaway of this whole problem, and that shows up on the quiz as well, or the test, is that g prime is given by the function f, or you can, in other words, you can graph g prime by looking at f, okay? So then they want g prime at 2. So g prime of 2 is going to be equal to f of 2. So all you have to do is look at the function here at 2, and you can see that f of 2 is 1. So g prime of 2 has to equal 1. All right. Questions there?
No.
All right. Meandering on here, part C. Find the absolute minimum value on g on the closed interval from -2 to 4. Justify your answer. So again, we're looking for the absolute minimum of g, and remember that we can use the derivative of g to find mins and maxes, right? So g prime of x is equal to f of x. So if I look at f of x and I find the zeros of f of x, those are potential extrema of g, and so it would be a minimum if the derivative went, well, if the original function went from decreasing to increasing. In other words, if the derivative went from negative to positive. So we're going to look at our graph here, and we're going to see, are there any spots where, well, are there any zeros? Turns out, yeah, there is. There's one right here, and there's one over here as well, okay? Here, the graph goes from increasing, well, the derivative is positive, so g must be increasing here. Whoops. G must be increasing here and then switching to decreasing. So that's going to be a local maximum there. Okay. Actually, let's put that there at 3. Okay, so that's not going to work. The other spot is here. In this spot, it's going to be increasing until you get to this point at -2. So that's going to be, well, no, I'm sorry. It's going to be increasing from the point -2. So the original function would start somewhere, right, and then start increasing from there. So I think this is going to be an endpoint that is the minimum. Okay, so we'll write that down then. So g prime of x has an absolute minimum at x equals -2. Okay, and then the justification for that is that, for all that, so how would you write this mathematically, or like the AP would be happy with, g prime, or well, there's a couple ways you could write it. You could write since g prime of x is equal to f of x, and f of x is greater than 0 when x is greater than -2, and f of -2 is equal to 0, then, or I guess you should say therefore, g prime has a minimum at -2. So therefore, that. All right. Whoa, get rid of all that red stuff here. All right. Okay, cool. All right, part D then. Part D says the second derivative of g is not defined at x equals 1. Quick confirmation. Yeah, no, that's right. We got a corner there. So the second derivative of g would be the derivative of f. Okay. So then it says and x equals 2. Which of these values are x coordinates of points of inflection of the graph of g? Justify your answer. Okay, so we want to know which of these are points of inflection in the graph of g. That is, we want values that, so this would be changes in concavity. It's the best way to explain this. All right, so here's your graph, right? Potential changes for concavity show up here and here, as they talked about in the in this, right? Those are potential changes for concavity. Changes in concavity will result when there is a change in increasing to decreasing or decreasing to increasing in the derivative, right? So if you've got a graph of f prime, so here's my f prime graph, and you go like this is going to end up being an inflection point because it's going to be a 0 of the second derivative where there is a change from increasing in the derivative to decreasing in the derivative. All right. Right here we have we go from increasing to decreasing, and then here we go from decreasing to decreasing. So I believe the only point of inflection is going to be at 1 right here. Let me check my answer. They say there is a point of inflection at x equals 1 because f equals g prime changes direction from increasing to decreasing. There's no change. Yeah, okay. So basically what I just said. So I can just kind of write that down real quick to completely finish this out. Whoops. So x equals 1 is an inflection point. X equals 2 is not. And then, you would write out kind of what I just explained, but I don't think there's a reason to rewrite that. So, I think that's it. Any questions on that?